Hello? Yeah, I think you can hear me, right? Yeah. We'll it's 10:30, so we'll give it a slow start. So first of all, maybe some of you can deduce by my name, I'm not a native speaker. And in my native language, there are similar words to distributed and delegated, except pronounced differently. So if by the end of this presentation I start talking about delegated and distributed, it's still about the same stuff, right? It's just that I'm getting tired. So that's just a head up. So yeah, distributed and delegated access management is the topic of this talk. And before I dive in, I was just looking for a quote a few weeks ago about the identity and access management world as a whole. And I just wanted to give people an understanding of the increasing pervasiveness, if you will, of this industry and the technology. And yeah, the SNS Insider research has kind of pointed out that the market will surpass $40 billion in 8 years from now, and that's a 330% increase from where we are today, or where we were last year actually. And yeah, that's mostly because we start using more and more applications. We do business more and more digitally, and identity and access management is becoming more and more important. And as a matter of fact, we got a new dishwasher a few weeks ago, and lo and behold, you can connect it to the Wi-Fi network and actually log on to it to configure it and to operate it. And that required me to get an account online first, you know, to register and to get access to my own dishwasher, you know. And if you can imagine that if the number of devices in a single household like mine increases, and we're dealing with, I got 4 kids, you know, we're dealing with different household members, the household in itself will become what is an enterprise business today, like with lots of people getting access to lots of applications and devices. And how do you control all of that access, right? Because imagine if I want to delegate some of the things to my kids and keep full control myself. How do I take care of that? How do we get insight into that? And how do I manage that on a scale? And that's just the household, you know. Imagine consumer identity problems and enterprise IAM problems in a few years from now. So mostly this talk will be not about the identity management problems per se, where we talk about user account management and the life cycle of user accounts and authenticating users. This is about this side where you provide access to those users to applications and how you manage the access. And hopefully this talk is about how to make access management manageable again. Anyway, that's just a small introduction. This is the outline of the talk. I'll first go into some of the history of enterprise web access management. Started around the end of the 90s, beginning of the zeros, where we had a very specific defined way of doing things within the enterprise. And then, of course, the cloud and mobile came around, and we had to change things, the way we do things. And we came up with new protocols for identity and API security, and we started to migrate the applications that we were using within the enterprise so far, migrate them to the cloud. And that is not without its own challenges, as we will see. Then we'll talk a bit about sort of a new model for access management that spans both on-prem and cloud environments. And I will talk about the ability to switch between centralized and distributed and delegated access management and end up with some takeaways in the summary. Okay, so let's go first to the brief history on web access management. As you may know, enterprise single sign-on and web access management in the 90s, early 2000s consisted mostly of buying into a vendor that would provide you with an access management product, a big server that would hold all of the enterprise identities and entitlements, and you would hook up applications to it that would consume a cookie that was issued by this big authorization server. And that would be a domain-wide cookie, right? So at the beginning of the day, users would log in to their workstation and to a central portal. They would be issued a cookie into their browser, and that cookie was valid for the workday and would give them access to all of the applications that run within the corporate perimeter, and they were happy, you know. That worked reasonably well, except for the fact that everything had to go through central IT, right? So the onboarding of applications and the management of entitlements would all go through centralized IT, and the application owners would have to interface with the corporate IT team to onboard their application and to also change things into the entitlements and the access control that they wanted to apply to their application. And the other thing that was very noticeable back then is that in order to hook up your applications, you would have to do stuff to it, right? You have to do stuff to your applications to connect it to your SiteMinder and your Oracle and your IBM infrastructure. And that will usually consist of having an application-specific plugin that's called an agent. And we'll get into that later a bit more as well. So that is basically how it used to work, say 20 years ago. In real life, the things that I just described, web access management in real life back then was, firstly, you had to adapt your application to consume this domain-wide vendor-specific cookie. You would have to register and go through a process to onboard your application with the corporate IT department. You have to wait some time until it's onboarded, and then if you wanted to have some changes be applied, you'd have to go through the same process again. And this not only holds for the production environment, but also for the lower environments like test and acceptance. And it was basically a very time-consuming, ineffective, and a frustrating process as well, right? Because application owners would sit on their hands waiting for their application to be onboarded, then find out, oh, they did something wrong because it needed to be like this, and then have to wait again. And it's a waste of resources in general as well. But, you know, it worked for some time, and we were sort of happy, I think. Except for the agent part, of course, that I alluded to earlier. Those the plugins that would make your application talk to the central authorization server were based on vendor-specific software plugins to your application. Proprietary code, closed source, implementing a proprietary vendor-specific protocol that would allow the application to talk to the infrastructure. And it also meant that often you would end up with limited application support, right? Because you might have some awkward core application that you were running for more than a decade already, and the vendor simply wouldn't have a plugin for that application to hook it up to the infrastructure as well. So that would mean that you still, for 10% of your applications, you would have to issue an application-specific username, password, do the whole identity management lifecycle as part of your application as well, and still end up with like an uncovered area of applications. So that's kind of the downside of that model, and also the downside of using agents in general. Well, so all in all, that means that all of the access control to all of your applications back then was enforced through a single centralized component that only works for tightly coupled applications, right? Using a proprietary protocol that is very vendor specific. And if you may recall, if there was an upgrade that was required to the authorization server or to the agent in some way, there would be a flag day, like every application would have to get onto the new version of the agent, and then everything would reboot overnight, and hopefully it would work. Otherwise, you were in big trouble. And also the application management, so the access control and the enforcement would run through this centralized environment, but the management was also delegated to the corporate IT department, right? You would just ask them by email or tickets or whatever to do stuff that would affect your application as an application owner. And really, in essence, the core IT department didn't have any application knowledge, you know? They were just like seeing it as a generic web application instead of being aware of the consequences for end users and how it was supposed to be used and what it meant for the entitlements, etc. And they didn't really know how to qualify specific requests. They just said, oh no, you can't do that because it will open up things to this and that, and we're not going to do that, right? Without understanding that it was actually perfectly okay to do that. So stuff like that made things a bit cumbersome at times. And then, of course, we saw the rise of cloud, right? Around 2005, I think it was AWS was the cloud environment that came up, and the adoption of SaaS as well. So this meant that the applications were no longer just sitting in the enterprise network, in the corporate perimeter, but it would be regular SaaS applications offered by third-party vendors, and there would be applications that you would run in another party's environment, in another party's data center, not as part of your corporate network. And this also meant that we could no longer rely on people being signed into Windows terminals in the corporate network, for example, and trust the fact that if you were connected to that corporate network, maybe even through VPN, that means that there was some form of authentication that happened already. By now, we just had to assume what some people call identity is the new parameter, like authenticate users and then go from there, instead of assuming that, okay, on this network we're kind of safe. Some others call that the zero trust networking principle. And also, we had more and more mobile workers, right? People expecting to be able to work from home or to be able to work from their local Starbucks. And this, of course, increased in the last years with the advent of COVID, where people were forced to work from home, not being connected to the corporate network anymore. And a fourth factor that was important here is the rise of the mobile apps, right? The native mobile apps. So for some time we saw a war between using browsers and applications that would actually behave as browsers to run between mobile phones and the applications, but it became apparent that it didn't really work as well UX-wise, and there were some problems with other areas, and people started developing native applications more and more. But native applications means it's not a web application, it doesn't use cookies, it cannot rely on traditional single sign-on protocols, so we had to come up with another set of ideas and protocols to deal with the native apps in the same way that we dealt with the web apps. So, this, of course, led to development of new protocols, a set of modern identity and access management protocols that would allow to overcome the limitations that I just talked about. It would work across web applications and mobile applications. It would be lightweight so that we could easily implement it as part of our applications and hook it up to identity providers with a standardized protocol, right? So driven by SaaS, cloud, and mobile, we came up with a lightweight set of standards that was based on REST and JSON rather than the old XML, SOAP, and SAML world that was most dominant before that. And those protocols predominantly were OAuth 2.0 and OpenID Connect. I won't go in any detail on those, but it meant that you could use an application-specific token rather than a repeatedly used username password for every application to sign into those applications, which mitigated what is called the password anti-pattern, where we would have to create accounts, just like I had to do for the dishwasher, in every application that we wanted to use, and we would typically use the same username and password all over again, because that's the thing that we can remember, right? So that may have worked within an enterprise, because nobody cares if you reuse the same password within the corporate network or within the set of applications that it's managed by your organization. But it becomes a bigger problem if you log into applications operated by third-party application providers like SaaS providers and third-party mobile app developers. So that is what OAuth and OpenID Connect catered for, to do that in a more secure, scalable, and last but not least, standardized way. And then coming back to the agent thing, so this also meant that because those protocols were lightweight and kind of easier to implement, we could now redo that interface between web applications and the authorization server based on standards, right? So OpenID Connect used that as the integration protocol instead of the vendor-specific closed source proprietary protocol. This also meant that you would see a rise of open source implementations of application plugins, right? For every open source application, there would now be an open source OpenID Connect implementation as well that would be bundled with the application, and you could hook it up to an OpenID Connect compliant identity provider. This in turn led to wide adoption for all applications. Like the problem that we saw before, that 10% of the applications would just not fit to connect to your vendor-specific web access management product. That is now gone because you can find a wide range of plugins that were developed and supported by various parties in the open ecosystem that would allow you to hook up your application in an OpenID Connect way to the gateway. And if you would have legacy applications that you simply cannot change, you cannot do anything to them, either because it was based on some awkward programming language or framework that no longer gets developed or supported, or it was developed a long time ago by somebody who left the company and nobody dares to touch the code or the application, there's always the fallback to header-based authentication, which means that you put something in front of that legacy application, and that thing terminates the standardized protocol like OpenID Connect, and then sets a header, creates a session, and then propagates the user identity information inside of headers to the legacy application. And that is a pattern that often was used even in combination with those web access management gateways, and it's something that was seen from 30 years ago as, okay, we can do this to authenticate users, and it's very easy to support. Like, just consume a header and rely on an external component for all of the difficult stuff to handle security and to handle user identity. And that pattern is, by the way, something that is pretty popular in various environments. We'll come back to that as well. So the whole agent issue and also the flag day upgrade issue is now gone because the protocol stays the same. There hasn't been any upgrade to OpenID Connect in 10 years, and even if there will be ways to upgrade in a more granular fashion than to do it as a flag day that we used to do before. So then we could think about migrating the legacy web applications that we developed specifically for the enterprise and migrate them to the cloud, like host them in AWS, host them in Azure. And yeah, as I said, those legacy web apps, we know they cannot be changed, right? So rather than trying to implement OpenID Connect as part of that legacy application, we could actually rely on infrastructure that is put in front of it, a reverse proxy, if you will. And even the likes of Amazon did that with their application load balancer, where OpenID Connect was implemented as part of the load balancer, and then the applications residing behind it wouldn't have to care about security or establishing user identity. It was all taken care of. And basically that idea of externalizing authentication and authorization into a dedicated component, that is something that I actually talked about as well at Identiverse in 2019. So I won't repeat all of the reasons to do that, but you can find that presentation and take a look for yourself to see the benefits that fall out of that paradigm. And just one more thing that I would like to add, because Vittorio Bertocci talked about single logout yesterday and the difficulty to achieve this. Well, using that paradigm of putting your applications behind a reverse proxy with a single OpenID Connect implementation also makes it a lot easier to achieve single logout, because you don't have to rely on dodgy plugins that may or may not support stateless backchannel logout, whatever. You can just, again, outsource all of that difficult security stuff to a dedicated component. And yeah, you can do that for the authentication with a single sign-on, but that pattern can also be extended into access control, as we'll see. So yeah, that would allow you to leverage the modern protocols that we developed to deal with the cloud and mobile era without changing that legacy web application, which is probably something you never wanted to do in the first place. So then we get to the more heart of this presentation. That's a model for modern access management, because by now we've seen all the components that are involved, all the challenges that we have, all the moving parts, and we have to realize that whatever model we come up with, it has to be accommodating for a mix between cloud applications, SaaS applications, applications hosted on AWS Azure, and applications still hosted in your own data center, and applications that live within the corporate network, right? And definitely this means, and by now I think everybody is convinced about that, this means that all of those applications will be somehow connected to a corporate identity provider running SAML and OpenID Connect and OAuth that is connected to a single directory server, most of the times being Azure AD in this time, or Active Directory on-prem, if you will. But that concept, wherever the directory resides, or whatever protocol, standardized protocol you use, that concept, SSOing into a corporate identity provider is definitely a starting point for anything you're going to do. And then kind of what I've seen more and more these days is that you try to externalize the access management from that application-specific implementation as well, by outsourcing the access management to a central component, and the access management, the access enforcement to that reverse proxy layer that I was talking about, so that you, your application and your application developers are not burdened with that task. How to do that, we'll talk about that in a minute, but the general idea is that you kind of pull out all of that access management out of the application and make it available in a sort of a centralized way, but then make it accessible for application owners themselves. And that is really the heart of this as well, that application owners actually own the access management, right? So that they don't have to rely on corporate IT and procedures to go through, because ultimately they know what they are doing, and if they want to do things differently and they want to screw up, they can do it anyway in their application, right? So there is no point for corporate IT to be in the middle of all of that. We were forced to do that 20 years ago, but that's no longer the case, and I will go into a bit more detail on how to achieve that. But it kind of means that you will have no application-specific roles or entitlements in your corporate AD. It doesn't belong there. That is managed somewhere else, that is in a different place, and is also managed by the application owners themselves, rather than in a central, in corporate IT doing that. So that's the model. And then more specifically, it turns out, in my case, or in my proposal, to be two-tiered enterprise access management. It consists of two tiers. Tier 1, we talked about a bit already, is core and coarse-grained, as I call it. And it takes care of the account management lifecycle and the single sign-on that we saw before. So the SAML, OpenID Connect, is all terminated in a central identity provider, and the management of identities is all taken care of there. And then we have a tier 2 that is application-specific and more fine-grained, to do very application-specific access control and to manage the roles and entitlements for the application. That's the tier 2. And mostly this happens for the workforce applications, right? For the workforce use case, employees getting access to enterprise applications. But you can easily, well, not easily, but you can use the same paradigm for consumer-facing identity. It's just that consumer-facing identity was never on a large scale solved with this classic web access management product. It didn't have the same challenges, so that's why we'll leave it somewhere in the middle here. But the same model that we're describing here can be used for customer and consumer-facing identity. And yeah, the tier 2 would work across on-prem, hosted, and SaaS applications. So let's dig a bit into that tiered model. So the access management tier 1, as said, is operated by the corporate IT department. It's the user account management in your directory server, the lifecycle, the onboarding, the offboarding, the authentication of users. Introducing two-factor authentication can be done at that location. Only in a single place you introduce two-factor authentication and leverage it instantaneously across all of the applications that connect to your infrastructure. That's a very powerful paradigm, and that's definitely a burden that you don't want to be part of applications themselves. Outsource that. We have all of the standards to do that. Use them. And if you can find OpenID Connect implementations out there to embed in your application. And if you don't want to rely on OpenID Connect because you think SAML is better, by all means go ahead and use that. It's not a problem. It's just the fact that you're using a standardized protocol is the most important thing here. And as a part of that same tier, we have the application onboarding that we saw earlier as well. That's also part of this tier and happens in a more dedicated component as well, whereby application and owners can do that. And that component is called the Access Management Portal. And over the last 5 years, I've seen more and more large enterprise customers use something like this. It's just actually a web application, so application owners can also SSO into it, and they have the rights then to onboard, to announce, to configure an application, right, that they want to hook up to the infrastructure. So application owners go to the central portal, the access management portal, kind of like logging into what central IT did into the web access management component, but now it's kind of delegated. It's delegated to the application owners themselves. They have accounts already, enterprise accounts. They log into that portal, and they, in some way, get access to announce and to configure the application and the entitlements that go with it, the roles, all application specific. That is stored somewhere, again, in a central location. But the big part is that this central location is then used to push out application-specific configuration into, for example, that reverse proxy layer. So rather than applications calling back into the web access management product or a central component to find out what the user is able to do, that information was actually pushed beforehand out to the applications themselves. And if we're talking about using this reverse proxy layer that I talked about, it will just configure the reverse proxy layer to say, okay, this path is accessible to this class of users, and this path is accessible to the administrators, for example. That's the stuff that you can do on a more fine-grained level. So in the tier number 1, you would actually decide on whether the user is authenticated at all, whether the user is who he says he is. And then in the tier number 2, you would actually solve that application-specific access problem. So whenever we're talking about a reverse proxy layer, it just means that you have to configure that reverse proxy in a certain way. And we used to think that this is kind of hard-coded stuff where people go in to configure an Apache server or an Nginx server and then restart that thing, and it's out of control in some way. But with the advent of containerized technologies and with the advent of things like Ansible, Chef, and Puppet to manage configuration in a versioned repository as well, you now have the ability to very dynamically control that set of reverse proxies and then restart instances or clusters of instances to consume that configuration. So this is kind of the part of the distributed part, right, where you no longer rely on central infrastructure that you call back into, but it's all has been pre-provisioned. You run your tier 2 in a pre-provisioned way, independent of the central infrastructure, which gives you a kind of an independency and a flexibility as well. I think I went ahead of my slides already and talked about that reverse proxy layer. So remember this reverse proxy layer, you can instantiate this or see this in any clustered or segmented way that you want, right? You can have one reverse proxy, right? A single reverse proxy in front of all of the applications that you provide to your employees, for example. most people will say, that's not going to work for me. That's not a problem. The paradigm is still the same. You create a whole cluster of proxies that you configure in the same way and reboot containers, etc. That's fine. People might say, that's not good because maybe I want to reconfigure this set of applications and I want to bring down the reverse proxy and I don't want the other application to be affected. Fine. You just create different clusters for segments of applications. Or in the ultimate case, you end up with one reverse proxy per application. It's also a possibility. The concept remains the same, right? It's the configuration management that is done in an offline fashion and then pushed out to that set of reverse proxies. And yeah, this reverse proxy, in the cases that I've seen, is operated by corporate IT because they kind of know what they're doing. They have more knowledge in reverse proxy technology and web security in general. And so the operational management of this reverse proxy layer is typically handled by corporate IT. Again, if you really don't want that, there's no inherent need in this model to do it, right? You can also leave it up to the application owners to run those reverse proxies and consume that configuration push. But it's just a more natural feeling, I think, to a lot of people. It appeals that corporate IT is responsible for that. It's tightly connected to network connectivity as well, for example. And then again, yeah, the delegated configuration, application owners themselves are actually responsible for the configuration, for configuring it, right? Not for pushing it out. That's it. Yeah, so the access management configuration is an interesting part, of course, because this is still a central authoritative source. Rather than application-specific entitlements living all across the globe hidden inside applications, you do want to kind of pull it out into a central repository where you also have an overview of who has access to what and gives you more audit capabilities as well, for example. But you know, this could be done in any number of ways. You know, there's no defined. It could be in a database or a GitHub repository, and I don't think there's any real standard or anything that I would recommend for this. It's just a good idea to get this started, and then later on, there's a lot of developments in the access management world as well. You can start adopting, hopefully, new standards in this area as well. But the general concept is well known from the XACML days, where you have a policy administration point, that is that central portal, a policy decision point, that is that component that decides who does what, and the enforcement point, which is that reverse proxy layer that I talked about earlier. Yeah, I think I went ahead of the slides again, where this is about the configuration of that access gateway itself. Yeah, I don't think I have to add anything to that. Yeah, maybe this, I'm kind of talking about automating all of this, right? Automating the configuration, automating the pushing it to the containers and restarting, etc. But you know, within the same model, you can still do it as a manual thing, right? And you can even start this paradigm on a much smaller scale by just doing it in a very manual way without all of the fancy infrastructure that is required to automate it. It's more the idea, the line of thinking of delegating access control to application owners and enforcing the access through a centralized layer that is important here, rather than the kind of operational way of handling things. So this is an example of my PowerPoint skills. Yeah, I thought I should stop right there because it was never going to look fancy. So I left out the connections as well. But this is just to give you an idea of the set of components that I was talking about earlier. Your user accounts on the top right. Oh, hold on. I can actually do stuff like there. User accounts, that's a corporate Active Directory or your Azure AD. Your IDP, again, ADFS or Azure AD can do all of that, or your random identity provider implementation. And then next to that is the access management component that also stores all of the access entitlements in a configured repository, and you actually manage that through a central portal that is offered to all of the application owners in the enterprise business. And then the tier number 2 over here is a set of gateways that is sitting in between the end users that are here just above. See, over here are the end users, accessing the gateways and then getting access to the applications that reside behind it. Anyway, just to give you an idea about the architecture. So then when we look a bit deeper into the centralized versus delegated access management, so the management of this access control, again, can be left to the application owners, or it can still be done by core IT, right? There's no reason why you shouldn't do it. If you feel that is the way you want to operate it, fine, you know. But the option to have it to offer it in a delegated way or a centralized way also means that you are allowed to shift in between that and base that shift, base it on the, for example, the organization responsibilities. If there's a class of applications with application owners that you really don't trust to do that, well, keep it in your own hands, right? It being core IT. If there's an application type that is more sensitive, you might want to keep it in your own control. If there are certain infrastructure requirements like, oh, we don't want those guys to use our reverse proxy infrastructure or the other way around. We don't want them to do their own thing. You can allow shifts in between, like, okay, we are going to manage this for you, being corporate IT, or we'll just give all of the control to you. And that shift of centralized versus delegation is, I think, a powerful thing that you can still facilitate with the same infrastructure. And the fourth element is here is knowledge, right? If you're sure that some people don't have the knowledge to manage all of this and to deal with security or entitlements, then don't delegate it, right? But the idea that you can shift, so I see it as sort of a slider between centralized and delegated access management. That's a nice idea that you can maintain with this infrastructure. So that's the management, and the same thing happens on the access enforcement, right? So to enforce within or for applications what is, who's allowed to see what, who's allowed to do what. And that form of distributed access control, you can facilitate it by externalizing things from the application, right? By in the way that I described, by doing it in a central repository and having the enforcement done in a dedicated layer that sits in front of the application, or maybe even embedded if you really want to do that. And again, you're not restricted to either distribution or do it in a centralized way. You can also shift in between that if you want to. And the cloud readiness is based on the fact that in this way, by pushing it out to containers and reverse proxies and applications themselves, they don't have to call back into a central server, right? Which doesn't really scale all that well and doesn't really work with cloud-based applications anyhow. And this brings me to the conclusions already, and some key takeaways, I think, that I guess you've seen by now for yourself. So first thing I want to say is that the modern access management across applications living in the cloud and on-prem can be handled through a dedicated access gateway. And this is one of my hobby horses, right? So I felt I have to repeat it here because it also gives way to the delegated access management that we talked about here. This is a primary principle that I still think is very valid and I see popping up in lots of places. And then the configuration of the distributed access management and enforcement can actually be achieved through container configuration management these days, right? We have lightweight container environments where we can spin up stuff and bring it down and configure it through APIs and things like Ansible in such an easy way. That's a complete different era from where we were 20, 25 years ago. So leverage that to achieve this goal. And then we can allow shifting between delegated and centralized access management and the enforcement within the same infrastructure. I think that's a powerful thing to have as well. And the web portal, the access management portal, is another important thing that I see popping up here and there with customers, for example. So those are my conclusions and takeaways. And I went ahead a little bit and came up with some questions that you will probably have. So I want to take some of them out of the equation here. Like, are you or you're providing, is your company providing this? And that's a no, right? It's not like I'm trying to sell you anything directly, I want to say, but this is more of a description of an approach that you can follow, and a description of an approach that I've seen appearing in the enterprise identity and access management more and more. And it is also likely that you already do a part of this yourself today in your enterprise business in some way, right? You may have a set of reverse proxies already, you may have an access management portal, et cetera, et cetera. So if I'm not providing this, and there is no company that's providing this, do we need to build this ourselves? The answer is possibly, because I don't think there's anything out there that you can just say like, okay, we're going to use this in this way. But it also depends on your needs, right? So I've seen, for example, Netflix is one of these companies that just built this stuff, all of this stuff themselves and make it work, right? I don't know if you want to go that same way, but so the third question, can we purchase this from another company? Parts for sure, right? So I talked about the Amazon load balancers that implement OpenID Connect. You could leverage that as the access gateway tier that I described. There's the Ping Central thing from Ping, my previous employer, by the way, that offers delegated access management in some form already. Last year there was a company providing the reverse proxy layer as a SaaS itself. I walked across the exhibit hall, and there was a company providing a cloud-based access management solution, right? So that database that I talked about, they would offer a cloud service for that, and also the integration into applications. So not using a reverse proxy layer, but pushing access management entitlements directly into applications that live in the cloud. So that's another way to do it. So those are some of the questions and some of the answers, and that leaves us just a few minutes for any other questions that you may have. So go ahead. Sorry, I should, can somebody pick up the mic that's residing over there? And this is, I should also warn you that this is being recorded, so.
Yeah, hi. A question. We're having success finally now that applications are able to do just-in-time user account provisioning, right? It's not common, but it's out there now. That would be a nice addition to this current state recommendation, and maybe more apps could pick that up. Based on SAML assertions and group membership and that kind of thing, they have application roles developed.
You're right. I didn't even think about this, but that is a first step in falling into the same paradigm, right? The provisioning, just-in-time provisioning based on assertions that come in, rather than relying on pre-provisioned accounts. You could see that in the same way, indeed. But I tried to focus on access management here, and this is more about the identity lifecycle, but it could perfectly fit within the same infrastructure, I think. Yeah. Yes, do you perhaps want to wait for the mic, or shall I try to repeat your question? Yeah.
Just wondering, for authorization, we're using RBAC, ABAC, PBAC, or none of the above mix?
I'm not endorsing any specific way of storing your access management or representing your access management information, or even exchanging it with anything else. There's been protocols and efforts, and sometimes people renaming the same thing, because some of the things that you mentioned are in fact, I think, the same thing over and over again. I'm staying away from that deliberately. And in fact, I'm not even an expert on that field. I'm just talking about the architecture in general, and not about the format of how you store access management policies or what you use to communicate them to other parties. I don't think I'm qualified to say which one is better or not. I'm just expecting developments in that area because nothing has really picked up as the standard or the way to do things, you know. We're still evolving when it comes to that. Yeah. Any more questions?